Hi, everyone. My name is, wait, hold on. Do I have slides for this? Are there slides? Oh, perfect. Hi, my name is Clay. I am a PhD student at UT, and I'm one of the co-founders of the BioML Society. And so we are a group of mostly graduate students with a few faculty who are focusing on biological machine learning. So in particular, we tend to do a lot of education on AI for the life sciences. And as Steve mentioned, we put together a curriculum that has since become an official course at UT. We host guest speakers from all across the industry in the field. And recently, we've put together some open science events that engage the broader community. And if you're interested, please come attend one of our meetings, check out our website. We'd love to talk more. And so we work with proteins primarily. We're very biochemistry focused. And we decided to do a protein design competition to help, first of all, do some outreach with the community, and then also to figure out which protein design tools work best for making novel proteins with AI. And so there's all these tools out there. It's hard for us to know which actually work best. And so we, with some collaborators that we got in touch with through the Dell Medical School, we had the opportunity to test thousands and thousands of these proteins. And so we solicited designs for a task from all across the world. And so we formed the Bits to Binders competition. This ran in the summer of 2024. And we had over 60 teams enter from over 40 different countries and 85 different institutions across the world. And the task that we asked the competitors to do was to design proteins that can bind this cancer antigen called CD20, which is present on B-cell lymphomas. And these proteins were tested in the context of CAR-T immunotherapies, in which they served as part of the engineered chimeric antigen receptor, which can then guide the engineered T-cell to the target to help eliminate it. And so we asked the teams to submit designs for this, and in total we collected 12,000 designs from all sorts of different methods, and we wanted to figure out which ones work best. It's kind of like a bake-off to see what the best methods are out there. And so from this, we tested them all in the context of CAR-Ts, and we found that over 6% were functional from the pooled screen that we did. And this is actually way higher than we expected for our hit rate. We were expecting like a 1 in 1,000 chance of success, and this is over 60 times that. And so we were pretty blown away by that. And to confirm that these are actually working, we brought around 10 of them to a series of individual functional assays. And this includes seeing whether they have antigen-specific cytotoxicity, cytokine release, proliferation, and expansion. And from this, we found that 7 of these 10 worked, which means that we feel pretty confident about this whole thing working in general and that people were able to make successful designs. And so in summary, what this means is that competitors from all across the world of all different backgrounds using different methods were able to create candidates, immunotherapies that can help target and eliminate cancers. And so we found this pretty mind-blowing. And we're currently working through the data to figure out which methods and general trends we can elucidate from this data and which ones work best so we can help inform the community and make design even better in the future. And so as a whole, we think this event was pretty successful in showcasing UT's ability to be the forerunners of BioML in the world. And so we were covered in Nature, we made some fun trophies for all the winners, and we've had some of the professors on the winning teams actually specifically shout us out in getting future awards since this competition. And so this competition was a lot of work and it had a lot of moving parts, and I couldn't have done it without all the amazing collaborators. In particular, I think here today are Ty and Steve Ecker. Thank you very much. And then also we had some amazing sponsors as well who donated not just money, but also their time. And in particular, I want to shout out the Dell Medical School as well, because without the initial introductions that they gave us to some awesome companies, this would have never happened. Thank you.